All right, so here's some help for your Chapter 3 test, this Chapter 3 test review sheet. So let's get started. This problem is all about graphing a quadratic function. So let's walk through all of the different parts. Part A says to identify the y-intercept, and you can always see the y-intercept is the constant on the end. So the answer for part A is going to be -3. And I'll just go ahead, since we're going to graph all of this anyway, I'll just go ahead and plot this as we go. So our graph should cross the y-axis at -3. Letter B says to identify the equation for the AOS. So once again, the formula to find the AOS is the opposite of B over 2A. And so when I apply that formula in this case, it's the opposite of B, which is -2, over 2 times A, and A is +1. So when I do this little calculation, -2 divided by 2 is -1, but the opposite of, that's what the formula says, the opposite of -1 is +1. So the equation for the AOS, it's always a line, it's always a vertical line, will be x equals 1. So here's the line x equals 1. Okay, somewhere on that line is my vertex. That's going to be part C. So the vertex is then a point. And now it's our job to find out what the y-coordinate, the x-coordinate has to be 1. So what's the y-coordinate? So to find the y, we just put 1 in for x in this function and see what comes out. So 1 squared is 1. 1 minus 2 is -1. And -1 minus 3 is -4. So the vertex is the point 1, -4, which is right there. And because of symmetry, I can go ahead and match up this y-intercept point. It has a matching point on the other side of the AOS. And now I just need one more point to finish up my graph, and we'll do that in just a second. We'll just go ahead and work through our letters. Identify whether there's a maximum or a minimum value. Well, since the parabola opens upward, that puts the vertex on the very bottom. So in this case, we're going to have a minimum. And it says to find the value of the minimum. Well, the value of the minimum is whatever the y-coordinate of the vertex is. So it's just like this. The number that would tell us how high or how low a point is, that's all determined by the y-axis. The y-axis runs up and down. So when you're looking for either the minimum or the maximum value, you just take whatever the y-coordinate of the vertex is. And so in this case, that value is -4. All right, so letter E says use the graph to provide the solution. All right, so let's just go ahead and finish my graph, because the solution is going to be where this graph crosses the x-axis. Obviously, it's going to cross in 2 different places. So let's see if we can figure out where. I'm going to do a little xy input-output. So I'm going to input 3 into this function and see what comes out. So 3 squared is 9. 9 minus 6 is 3. 3 minus 3 is 0. Okay, so that's nice, because I know that one of my solutions to this is going to be x equals 3. And the other solution will be the matching point on the other side of the AOS, and that will be -1. So I'm going to go ahead and complete my graph. And it illustrates where the solutions are, the x-intercepts. So for letter E, I'll just go ahead and put it over here. The solutions are x equals 3 and x equals -1. And then our last step is to identify the domain and range. So the domain, of course, for all these parabolas is going to be all real numbers. And the range, it's all the y's that are, they start at -4. So just look at the y-coordinate of the vertex again. And they get greater than -4. So y is greater than or equal to -4. And that completes this first problem on your review. You got a problem pretty much just like that on your test. Okay, the next set of problems deal with operations involving the number I. So this first problem is a subtraction, and I'm going to get rid of the parentheses. And to do that with this second complex number, I'm going to distribute -1. -1 times 7, -1 times 5i. And now we just combine like terms. So I've got two real numbers. 3 minus 7 is -4. And I've got two imaginary numbers. -2 minus 5i is -7i. And there's my answer for number 2. Number 3 is multiplication. So for multiplication, I have to use the FOIL method. For the first terms, multiply together. 3 times 5 is 15. The outside terms multiply together would be minus 18i. The inside terms multiply together would be plus 20i. And then the last terms multiplied together would be -24. And I times I is I squared. But remember from our last test and other lessons, I squared is equal to -1. So anytime I write I squared or I see I squared, I'm going to replace it with -1 and continue simplifying. Okay, so in the middle, I combine these, and that's plus 2i. And then -24 times -1 is plus 24. And then to finish off my answer, I'm going to combine these two real numbers. 15 plus 24 is 39 plus 2i. So there's my answer for number 3. For number 4, my first move is to simplify the square root of -49. Now this is multiplication here. I noticed on the last test, some of you were changing this to plus or minus, but this, when there's no sign between 6 and the radical, it implies multiplication. So the square root of -49 is 7i. And when you multiply 6 times 7i, that's 42i. And I don't want to leave it like this because the correct way to write a complex number is to put the real number first and then follow that with the imaginary number. So my complex number answer for number 6 is -9 plus 42i. For number 5, I'm going to replace I squared with -1. And when I do, -3 times -1 makes +3. And now I can just multiply these together. 5i times 3 is 15i. For number 6, the way I simplify these fractions that have complex numbers in the denominator is I use the complex conjugate. All right, so easy to remember what the conjugate is. Just use the same complex number, but change the sign in the middle. Okay, so on the top, you're going to distribute 4 times 3, and then 4 times -5i. 4 times 3 is 12. 4 times -5i is -20. On the bottom, you could do FOIL, but with conjugates, the outer and the inner terms of FOIL will always cancel out. So you could save yourself a few seconds and just multiply the first two together. 3 times 3 is 9. And then just go ahead and skip to the last terms together. Positive 5i times negative 5i makes negative 25. 5 times 5 is negative 25, and then I times I is I squared. But again, I squared is negative 1. So when I replace I squared with negative 1, this makes negative 9 plus 25. Can you see how it's negative 25 times negative 1 makes plus, and 9 plus 25 is 34. So I'm going to write this as two separate fractions and then see if I can reduce. All right, so I just broke it up as two different fractions with a 34 denominator for both. And I can divide by 2 into both, so I can reduce. So this would be 6 over 17 minus 10i over 17. And there's my answer for number 6. For number 7, I'm always going to use an exponent for I that's a multiple of 4. So remembering the rule of multiplication, where you're multiplying two bases that are the same, you always add the exponents together. So remember that I to any multiple of 4 power is equal to 1. So I to the 24th is equal to 1. I to the 3rd is negative I. And so when I multiply those together, 1 times negative I is negative I. Number 8, just take these two at a time. So 2 times negative 4 is negative 8, and I times I is I squared. So think of that as negative 8 times negative 1, which is positive 8. And now multiply that times 6i, and you have your final answer, 48i. Number 9 is an addition problem, so just combine like terms. The real number terms are 4 plus negative 6, which is negative 2. And the imaginary numbers are negative 3i plus 2i. Negative 3 plus 2 is negative 1i. And it'd be okay if you left it like that, but usually when 1 is a coefficient, we don't write 1. So I'm just going to call this negative 2 minus I. And there's answers to that block of problems involving the number I. Then we get to solving some quadratic equation problems. This is from lessons 3.4, 3.5, and 3.6. So number 10, there's no way to factor this. It doesn't really say how we're going to do it. It doesn't really specify a particular method that we have to use. So I'm going to get x by itself using subtracting 27 from both sides. And then this is called the square root property, when you do the square root of both sides to undo that exponent 2. And whenever you do the square root of both sides, don't forget you're supposed to have plus minus, because remember we're looking for two solutions for a quadratic. So here we have plus minus the square root of negative 27. So I got some people struggling with simplifying these radicals. So just go off to the side and think about how you would factor out the square root of negative 27. I would use these 3 radicals. And these first 2 radicals can actually be simplified, because we know the square root of negative 1 is I. And we know the square root of 9 is 3. So the only one of these radicals that doesn't simplify is the square root of 3. So the final simplified answer here for this radical is 3i plus minus 3i, and then we're going to multiply that by the square root of 3. And there's my two answers for number 10. All right, 11 and 12 are solving by factoring. Use the box method when applicable. It's not applicable. Now, if you want to use it, you can. On number 11, you can use it anytime, but it's going to be required on this one because the number in front of x squared is greater than 1. So for number 11, it's just a matter of finding the factors of negative 15 that add up to negative 2. Obviously, we want to look for a GCF first, but there is no GCF. So I'm going to factor it as these two linear binomials. And it's a good idea to, if you have time on your test, go back and use FOIL and make sure you're factoring. I notice a lot of people, their factoring isn't even close to being right, and they've had time to check it, but they just don't. So if you've got time left over, go back and check your factoring, in this case with FOIL, and make sure that it matches, that it agrees. Now, I've done factoring, but I haven't done any solving at this point. Solving means take these two factors that each contain x and treat them as two separate equations. And now I've got solutions. I've got actual numbers that we could plug in for x to make the equation equal 0. Number 12, I'm going to use the box method, or if you prefer, you can use the AC method. So 2x squared negative 5. Multiply those together, that's negative 10x squared. And the factors of negative 10x squared that add up to negative 3x are negative 5x and positive 2x. And those go in the other empty spaces. And now find the 4 GCFs, both rows and both columns. Going across the top, that would be x. Across the bottom, that would be 1. So one of my factors is x plus 1. Going this way, it would be 2x. And remember, if both of the terms are negative, that means your GCF has to be negative. So the other factor is 2x minus 5. Okay, once again, I've done factoring, but I haven't done any solving yet. So take the two factors, let each of them equal 0, and solve. So my solutions are negative 1 and positive 5/2. Okay, so those are factoring method. Now let's complete the square on these. To complete the square, I'm going to need to move the 8 over to the right side, and I'm going to do that with subtraction. And that's going to leave a space for a new number. And the way I get that number is I divide by 2. Always remember to divide by 2, so that would be negative 1. And then negative 1 squared is going to go in both of these. Negative 1 squared is positive 1. Okay, and the reason why we did that is because this is now a perfect square trinomial, and there's a certain way to factor these. It's really just the square roots of these two end terms and bring this sign down. And on the right side we have negative 7. Okay, now I'm going to do the square root property, which is just basically the square root of both sides, plus minus. That gets rid of the exponent 2, and it just leaves me with x minus 1. And anytime you have the square root of a negative number, you have to factor out the number I as your simplified answer. And now I'm going to solve for x by adding 1 to both sides. And there's my 2 answers. Okay, next problem. This time I'm going to subtract 11 from both sides. And replace that number with a new one. And the way to get to the new number is divide by 2. 4 divided by 2 is 2, and then 2 squared is 4. So I'm going to add 4 to both sides. All right, and the factoring of that perfect square trinomial is x plus 2. Square roots of both m terms. Bring that sign down. And it just so happens we ended up with -7. Again, square root of both sides. So you know the drill here. It's going to be I times the square root of 7. And this time we just subtract 2. So similar answers. There's my 2 answers for 14. 15 and 16, you're going to need to know the quadratic formula. So let's just go ahead and show that. Opposite of b plus minus square root of b squared minus 4ac all over 2a. So my first move here is to look at my b term, and it's going to be -8, the opposite of b, plus minus square root of b squared, that's 64, minus 4 times 1 times 5. And all of this goes over 2 times a, which is 1. -8 plus minus, and under the radical it's going to be, remember to multiply these all together, so 64 minus 20 is 44 all over 2. And to get more practice with simplifying radicals, so the square root of 44, think of it as the square root of 4 times the square root of 11. I used 4 because it has the perfect square root. It can be simplified. So the square root of 44 in simplified radical form becomes 2 times the square root of 11. And now, since these numbers, -8, 2, 2, are all divisible by 2, this is just reducing. When you divide both parts of a fraction by the same number, then you're reducing. So I'm going to divide by 2. -8 divided by 2. 2 divided by 2 is 1. There's an invisible 1 here. And then 2 divided by 2 is 1. So we don't typically write 1 in the denominator. If you did, it'd be okay. I'm just going to show my final answer like that. All right. The only thing that has to happen here on number 16, you can't use the quadratic formula until your quadratic equation is in standard form equal to 0. And so we had to add 10 to both sides. All right, so here we go. Opposite of b plus minus square root b squared minus 4 times 1 times 10 all over 2. Okay, and under the radical, this is 36 minus 40. 36 minus 40 is -4. Okay, and the square root of -4 is 2i. And we got the similar situation as we had over here. We can divide by 2 to reduce. So 6 divided by 2 is 3. 2 divided by 2 is 1i. 2 divided by 2 is 1. So I don't need denominator 1. And that's my answer for 16. 17, we're taking a standard form quadratic function and changing it to vertex form. So there's some completing the square properties involved in this. So if you recall, when we completed the square, we took this middle number basically to get inside the parentheses. We did the square root, and basically to get this number, we divided by 2. We divided by 2, okay? We squared that when we added to both sides, but as far as the number that goes in the parentheses, we just took the number in front of x and divided it by 2. Okay, so that's what we're going to do here when we change the vertex form. All right, so x, square root of x squared, just bring down the sign, and then 6 divided by 2 is 3. Okay, so vertex form should always look like this. Now, a for you is going to be 1. So this is the general form of vertex form. So you can see a is 1, understood. Our h number is 3, and h represents the x-coordinate of the vertex. So when we find the vertex, we know that the x-coordinate has to be 3. All right, now let's work on the rest of this vertex form. So you're going to take this number in the parentheses and square it. So whether you think of 3 or negative 3, either way, the squaring is the result. That's going to result in the same number. It's going to be 9. And you're going to take that 9 and subtract it. Just take it to the end of standard form and subtract it off the end. And then just put those two numbers together. 2 minus 9 is negative 7. And so the answer to vertex form is here. And then identify the vertex. Well, we already had the x coordinate, and now we know the y. So there's the vertex. And so I'm going to ask you a similar problem on the test. You should be able to take standard form and change it to vertex form. Number 18 is discriminant, and to find the discriminant, it's just b squared minus 4ac part of the quadratic formula. Don't include the radical. All right, so b squared, 4 squared is 16, minus 4 times 3 times 6. So when you multiply those together, 12 times 6 is 72. So the discriminant is negative 56. And what does this tell us about the number of types of roots? Well, since the discriminant is negative, we're going to have 2 imaginary roots. No real number roots. They're both going to be imaginary. Okay, and then we always like to include a little review just to try to help you. The semester exam is not too far away, and so just try to keep some of this old material fresh for you. Each week, Carmen earns a base pay of $35 plus 17 cents for every pamphlet she delivers. So in part A, I want you to write an equation. It's going to be a linear equation. So our linear equations are in a slope-intercept form. And in this particular case, since her base pay is really determined by how many pamphlets she delivers. And so I'm going to let X be number of pamphlets. Spell that. And so Y is going to be pay, how much she earns. So remember, X is independent and Y is dependent. So just think of it this way. Her pay is dependent on the number of pamphlets that she delivers. So her pay is going to be found by doing this. Since pay is dependent on how many she delivers, and how many she delivers is x, then 0.17 really acts like the slope. Okay, as this number changes or increases, this is going to increase. And then we got this $35, which is, it's going to be paid regardless of how many she delivers. So the thing that's going to determine her pay really is this number, which is how many she delivers. More deliveries, more pay. Less deliveries, less pay. This is a constant. She delivers 1, she delivers 1,000. She's still going to get the $35. So there's the answer for part A. And then part B, how much is she going to earn if she delivers 300? So easy enough. I want you to take the equation that you came up with in part A, and X represents pamphlets, so replace X with 300. And just go to your calculator, and 300 times 0.17, I think is 51. Let me verify that. Yeah. And so we put those together, and that's 86. So answer a word problem with words. She will make $86 from delivering 300 pamphlets. All right, we're getting closer. Number 20 is solving a system of inequalities. And to do that, we're going to need to solve both of these for y. So I'll just do that horizontally going this way. So to solve for y, I need to subtract 6x from both sides. So my first move was to subtract 6x. And now my next move is to divide by -2 on both sides. And because I'm dividing by negative, that forces me to change the direction of that inequality. And -6 divided by -2, I'll just go ahead and show it like this so you can see it. Everything gets divided by -2. So negative divided by negative is positive 3x, and 12 divided by -2 is -6. And let's go ahead and do the same thing for this one. So my first move here is to subtract 3x from both sides. And then I'm going to divide both sides by 4. Okay, and now we're ready to graph. So let's we'll graph the red boundary line first. It starts at -6. And it has a slope of +3. Up 3, right 1. And it's going to be a solid, so I'm just going to do my best to draw sort of straight line. That's not very straight, but it's going to have to do. And then in just a little bit, I'm going to do shading, and I have to remember which side of the line to shade. And if you recall, less than always means below the line, so I won't shade yet, but this would be the underneath or the below side of that line. Now let's do the black. It starts at +3, and it has a -3/4 slope, so up 3, left 4. Or maybe you want to go down 3, right 4. Now, it doesn't matter where these two cross, they may not cross. There's still a solution. The solution for a system of inequalities is where these two shadings meet up. This is going to be a dotted boundary line. And now we're ready to do the shading. Let's just go ahead and point the direction. Greater than means above the line. And so for the black, that's this way. So the area where the two are going to share, they're going to collide, it's right in here. So I'll just highlight this area as any ordered pair that comes out of this area will be a solution for X and Y. And that's number 20. 21 and 22 come from lesson 2.4. And this is function notation. It means if you input -3 in for X, what comes out? So we say this as f of -3. It's going to be equal to -4 times -3 minus 8. And so now we just simplify this. -4 times -3 is 12 minus 8. So my final answer here, f of -3 is positive 4. Over here we're asked to find g of 5 using this g function. So -2 goes in place of x, and again in place of x. And now we simplify. Don't forget, powers come before multiplication. So this is -2 times 25. And this is going to be 20, 4 times 5. -50 minus 20 plus 1. -70 plus 1 is -69. And that's my answer for 22. And we just got 2 more. This goes back to our lesson on translations. I've got 2 parent functions here that have been translated from their original position, and one of them has been actually reflected as well. So number 23, that's the parent function absolute value of x, and it's been shifted 2 to the left. So I'll show that with plus 2 inside the absolute value, and then it's also been shifted 3 up, and I'll show that with plus 3 on the outside. There's my answer for 23. Now 24 is this quadratic parent, y equals x squared. Notice it's been reflected, so I need a negative in front of the parentheses, squared. So the original parent started here, but this has been moved 2 places to the right. So that's how I show a shift of 2 to the right and 3 up. Same way we did the other one, plus 3. So I counted for the reflection, 2 to the right, 3 up, and that's my answer for 24. And that is it. That's your Chapter 3 test review sheet. Your test looks a lot like this. So I hope this helps you as you prepare. If you have any questions, feel free to contact me.